Okay, Bismillahirrahmanirrahim. We have to discuss the ARDL cointegration. What happens is, suppose you have two variables xt and yt. And you are taking the difference. This is I1, this is I1. If you take the difference, what will it become? I0. So you have del yt which is I0. And similarly, if you take del xt, that will also be I0. Right? Now, you have studied the ARDL model. I am not talking about ARDL cointegration, I am just looking at ARDL model, which was a thing like this: alpha plus beta 1 yt minus 1 plus gamma naught plus gamma 1 xt plus gamma 1 xt minus 1 plus epsilon t, right. With some modifications, you can write the same model in this format. You can derive the model out of this: del yt is equal to alpha plus beta 1 yt minus 1 plus say delta 1 xt minus 1 plus say gamma 1, and you have del xt plus epsilon t. Basically, you can derive this second model from the first model. I am not going into the mathematics of this, just explaining what the logic is behind. But look, what is happening here, you have xt difference form, this should be I0, and you have del yt, this is also I0, but here are two variables which are without differencing, and these two variables are I1. The left hand side is I0. In the right hand side, you have this term which is I0, and then epsilon t is also I0, but this is the term which is containing I1 variables. But in order to keep balance, if left hand side is I0, the right hand side must be I0, right. There are two possibilities for this term, for this whole term to be I0. This must be I0. But how this can be I0? There are two possibilities. One possibility is beta 1 delta 1 is equal to 0. This is trivial case. This is equivalent to saying that you have excluded the xt minus 1 and yt minus 1 out of the model. This is something trivial, right. The second possibility is beta 1 and delta 1, these are not equal to 0, but the linear combination beta 1 time yt minus 1 plus delta 1 time xt minus 1, this is I0. The coefficients are not the coefficients are non-zero, and then you are taking weighted sum of these two numbers, and the weighted sum is giving you, this is I1, basically yt is I1, xt is also I1, and then the weighted sum is I0. If this happens, then this is equal to co-integration. This means this is co-integration. What is definition of co-integration? Yesterday we have repeated the definition of co-integration. What is that? If you have xt, which is I1, and you have yt, which is also I1, and then you have axt plus byt, which is I0, then what will happen? Then you will say that x and y are co-integrated. And with the co-integration vector, these coefficients a and b. This was the definition of co-integration that we have learned yesterday. Right? Now what we are saying, you have difference from variable on this side, this is I0, the difference from variables on this side, these are also I0, and in order to keep the balance, this must be I0. Right? Now there are two possibilities. First possibility is that beta 1 and delta 1 both are 0, then this term will eliminate. You have del xt, which is I0, del yt, which is I0. That is trivial case. The second possibility is beta 1 and delta 1 are not equal to 0, but if you take the weighted sum, that becomes I0. This is equivalent to what the definition of co-integration is. So in this case, the co-integration is equal to testing of this thing. Test for co-integration क्या बन जाएगा? If h naught beta 1 delta 1 equals 0, this is your null hypothesis, which is no co-integration. And then you have h1, beta 1 and delta 1 not equal to 0, which is equal to co-integration. So this is the basic logic behind ARDL co-integration. And the same logic applies to the Johansson co-integration as well. We haven't seen this Johansson co-integration so far. Maybe we will discuss this tomorrow. But there was some clever trick used by the authors of these papers. Basically, they said that you have a distribution okay. So you have this equation, del yt is equal to I have said beta 1 yt minus 1 plus delta 1 xt minus 1 plus say gamma 1 del x t minus 1 plus up to so on plus epsilon t. They said that look, if you have x and y both are I0, if x is I0 and y is also I0, and then you are making the distribution, what will happen, you want to test this thing as not beta 1 and delta 1 is equal to 0. You want to make the distribution of this test, this will be like this. Here is the critical value. Okay. Now suppose this x is I1, y is also I1. What will happen? You want to test again the same thing, and now this will have another distribution.